We are live. There we go. Okay, the spinning circle ended. Well, we have a lot to talk about tonight. We have severe thunderstorms on the way. The Mets just took the lead. There we go. And let's see, we have baseball. Of course, we have our Mets and Yankees all excited. We have thunderstorms. Will the thunderstorms impact the Yankee game and the Met game? Oh my God, what is going on? Well, let's check out the radar because we have a very impressive line moving through. This is from WeatherTap, and what we're seeing here is the first line here coming through. This has some very impressive lightning, which is not surprising based on what we were talking about earlier this morning when I did a premium public video discussion. We talked about the high levels of precipitable water value in the atmosphere. The reason why that's important is because the more precipitable water value that we have, the better the friction is in the atmosphere, more electrical charge, and so you get more vivid lightning. So we're starting to see that. Now, this thunderstorm complex is producing what we call straight line wind. We have already observed a tornado back in western Pennsylvania with the jet streak that is intensifying. Now, in this scenario, with this line coming through, you could see it marching to the east, but it's starting to take a bit more of a pivot to the northeast. So it looks like it might just pass to the north of Long Island. It's going to be close. But one thing that we really have to watch out for, I'm going to zoom in. Let's see if we can zoom in on this a little bit. There we go. Okay. When this storm comes through here, it's going to produce vivid lightning, very heavy downpours, wind gusts over 50 miles per hour, possibly over 60 miles per hour. And there's even this one producing a pretty significant hail shaft. So some pretty good hail here. As these storms are intensifying, an outflow boundary is starting to push out while this little mini sea breeze front is pushing in. Watch out, and the HRR is starting to pick up on this too. A cluster of thunderstorms to develop over Burlington County, Northern Ocean County, and right over Monmouth County that's just going to sit here and stall. That's going to be all based on the mesoscale boundaries. And you could watch these boundaries very, very nicely on the radars because what's happening is that you're getting an echo just enough to see these boundaries play out. And so with these boundaries playing out, you're setting up the environment for these thunderstorms to intensify. Holy smokes, and Alvarez just hit another home run. That is amazing. Now, what's also amazing is that with these thunderstorms lifting to the northeast, watch out when if you're watching the baseball game along with this, and I understand, please, I get it. If you're watching at the same time, let's see here, this is the third inning. By the fifth inning, you're going to see a strong wind come into the center field. And it's going to get very windy. And that's that outflow boundary that's going to build back towards central New Jersey. So right now, this line's lifting through. And it's losing a little bit of its punch because we're reducing the instability in the atmosphere. So you might be saying to yourself, Stephen, it's getting towards the evening. And we're talking about severe thunderstorm watches till midnight. How is that possible? Well, as you see, sometimes thunderstorms, especially in the summer, can thrive in an overnight period. How does that happen? Well, let's take a look at some of the observations. First of all, we have a lot of tropical moisture still here. You have this little trough here, prefrontal trough here, another one back here, and then your cold front way back here. You have plenty of humidity still left. You have a lot of moisture, and you have some minor instability. Okay, so you have pretty good lifting index here. I mean, -6 is pretty impressive. You see this color here, it's this blue color. That is a cap on the atmosphere. So under normal situations, yeah, this would mean that, hey, look, the thunderstorm potential is going to start to decline. But why isn't it? Why are we still expecting very impressive thunderstorms the rest of the evening? Well, it comes back to this jet streak that's developing. This is at 850 millibars. What happens in the evening hours and in the overnight hours is that this jet streak, which is the 850 millibar jet streak, sometimes called a low-level jet, intensifies at night. Now, this intensifies due to the diurnal thermodynamic gradient from the surface up to 850 millibars, and it allows for the wind speeds to increase due to divergence and diffluence and a couple of other equations that we can throw in there, but we're going to keep this simple. The reason why this jet streak intensifying tonight is so important is that it creates more mixing in the atmosphere. So it breaks the cap. So basically what you have here is that you have a bunch of soda bottles, right? The first soda bottle went off with this trough moving through, producing the severe thunderstorms moving through northern New Jersey. But you have a whole bunch of other soda bottles to the next of it that are getting shaken up. And with that shaking, all they need is a little bit of a trigger to explode. And so what we're seeing here is that the combination of this jet streak intensifying with these outflow boundaries starting to interact is going to act as that trigger. And so we're essentially seeing that in the latest HRR guidance here, where our storm lifts through, and this is working out pretty well compared. This is an hour older, okay? One thing, just so you know, with the model guidance, when you're using HRR guidance or NAM guidance, especially HRR guidance, anything that updates hourly, you don't want to use the one that's the freshest. You want to wait an hour to compare it to the observations to see if it's actually worthwhile using or if it's complete garbage. So this one is working out pretty well, right? It's showing pretty much the same setup that we are seeing in the actual radar. You see that lift north, and you can see also the lightning starting to lose a little bit of its punch, and you can see a lot of focus more towards the Hudson River Valley. Very impressive storm over northern New Jersey. So it is setting up so that it looks like it's working pretty well. Now, here is that outflow boundary influence there. And look at this thunderstorm that starts to open up like a zipper, okay? Or like you're opening up the cap of those soda balls that you just were shaking for 30 minutes. Boom. One after the other. And then the next wave comes through overnight tonight. So this looks like not only a significant severe thunderstorm event with very heavy rainfall, frequent lightning, downburst wind gusts. Is there a threat for tornadoes? I don't want to say no. And the reason why I'm not confident in saying no, it's not, is because I'm going to zoom in here on this urban heat island effect. You see this right here? Look at this. Okay. I want you guys really to focus in on this. This is really important. You see how these winds are pointing in towards the Delaware River Valley? And you see how these winds are pointing in towards the Delaware River? And you see this going this around Philadelphia, these very hot temperatures here? This is our urban heat island. And you see how these winds are kind of bending towards that urban heat island? That's leading to confluence at the surface. It's leading to a very low level area of confluence and lifting and turning in the atmosphere. This is usually not picked up very well in model guidance. And this is why when we really don't have any tornado watches out or any indication on the model guidance of tornadoes, you can end up with a weak tornado because of this influence of the urban heat island effect and this influence of these winds outside of the sea breeze effect that you're dealing with. This can lead to enough turning to produce an F0 tornado, and in some cases even a dry spout, which we had a couple of weeks ago. So what I'm concerned about is that is interacting with the jet streak and all this shear already starting to take place. And this right here, this is the start of our 850 millibar jet intensifying. Okay, so it's very, on the SPC site, you're just starting to get it going. Earth New School, same thing, just starting to get going. Now, as we move on through the overnight hours, let me see if I can pull this up real fast. I will duplicate this and let me pull up the winds real fast. I should have done it beforehand. I do apologize. But let's see here. 850 millibar winds. This is what I usually use every day. I don't know why I didn't pull it up beforehand, but that's okay. So what I want to show you, what I will show you as soon as I find it, there it is the jet streaks intensifying. Here are 850 millibars. And see that burst right there? It goes from light to strong. Let's see if we can get a better look at this. Let's see here. We'll use a different model. We'll clear this. Go here. And let's try with the NAM model guidance, or better yet, parameter 850 millibar winds. There we go. And let's use a mesoscale model. Let's use the HRR. We'll zoom in on New England. And let's take a look at what we have here. There it is. Okay. So notice this strengthening here that takes place, pushing up to 40 to 50 knots. So you have the winds that are intensifying. Okay, so that is your instigator for your severe thunderstorms and your breaking of the cap. What else is going on besides all of this? Well, remember when I was talking about all of the deep moisture? Well, let's look at 700 millibars. And let's see, we got relative humidity in here. 2 meter. Okay, not a problem. Okay, so this is what I wanted to show you right here. We'll use the skew T. As this storm is moving through, we still have quite a bit of dry air. Now, when these storms move through, you can see that you get this condensation. The concern here in this scenario, and we talked about this morning, is that with this type of setup, you get very strong downdraft winds. And this can lead to powerful straight line winds overnight. And so when we see this signal out here over southern New Jersey, that can definitely signify the potential for strong straight line winds and possibly an isolated F0 tornado being a threat. So it is going to be a very, very stormy night out there, and it's pretty much playing out as expected. Let's see if we can zoom out on the radar, and you can see again, here's everything turning. Looks like these storms are going to be clipping Long Island. It could have some impact on the Mets-Yankee game, but we can watch that live while that's taking place. There's our tornado signal out here. Again, not your typical setup in terms of a supercell with a tornado and a hook echo. This is more of a setup of you have those straight line winds and you're having a mesoscale low at the end of one of those bands to support that turning motion. A lot of the times when you have these thunderstorms, it's not always observed at the surface as a touchdown tornado, but definitely a circulation within the thunderstorm itself, more of a reminiscent of a mesoscale low. But certainly you should definitely take it seriously no matter what, as it still has all the other destructive properties with it. In terms of lightning, I'm seeing less lightning out here with this line. This one's chock full of lightning. I've been seeing reports on social media. A very impressive line here in terms of the lightning moving through. And again, as it's lifting up towards New England, it will start to run into more of a stable environment. It should start to weaken. We'll watch to see that outflow boundary start to take shape. In fact, let's see if we can get a different look here. Let's look at the one tilt. There it is. Found it. Okay, let's zoom in on this. Let's see. We'll do 4. Zoom. Let's see if we can get it loaded up. And I know it's taking a minute, but trust me. There it is. There it is. There's the clash. Here's your outflow. There's your sea breeze front. Your urban heat island effect setting up right here, and here comes your clash. So we're going to be able to watch this live and see how this all plays out. So while we're waiting for this to play out and show up to see what it looks like on the radar, I'm going to go and take some of your questions.
Busy on YouTube.
Yeah, sounds like we're busy on YouTube. We're busy here in the live chat for the premium members. And we'll check on X too, I guess.
Yeah,
if it
you're on X, you're not on Instagram. Just let you know.
figures. Well, last week it was the other way around.
X, yeah, I know, and that was a little bit problematic this week too. But
Figures. Okay, looks like, let's see. In the severe thunderstorm warning for Union County, how bad does it look like it will be the northern portion of Union County near 78? Well, it looked like it was pretty bad. I apologize for the delay in getting it. And the Mets got in a double play. Oh, nice. They got a double play. Very nice. Let's see here. Yes, I am also watching the game at the same time while I'm doing this. I can multitask. I've been waiting for years for the Mets to play well against the Yankees. I'm not missing it. Looks like it will hit during the chat. Yep, it certainly did. And the cells that are moving through northeastern New Jersey right now are featuring supposedly some hail. No signs of rotation at all so far in these thunderstorms. I've been keeping an eye on that, mostly just straight line winds. I haven't heard any reports, no sign of mesoscale lows or anything of that nature. So you and others say that once the sun goes down, thunderstorms tend to die down. Why do some thunderstorms and others be severe at night? If so or not, would this be the storm would be more severe during the peak of daylight heating? Okay, great question. All right, so we were talking about the 850 millibar jet. When it comes to mesoscale meteorology, it's very dangerous to stick by concrete rules because mesoscale meteorology is all about chaos, right? We're watching chaos right now with these boundaries getting ready to interact. How are they going to interact? Will they enhance lifting? Will they cancel each other out? Will they enhance the urban heat island effect by creating substance somewhere else? It's very difficult to iron out. Now, in many cases where you have the 850 millibar jet more displaced to the north, which we typically do, or it's weaker in general, as you lose the instability in the atmosphere, you lose the strength of the thunderstorm. And that's normally the case. However, in an environment where we have a lot of moisture, low-level moisture, I mean, just go out there. It's like a steam bath. And you have an intensifying 850 millibar jet, what that does is that it causes mixing in the atmosphere. And that mixing in the atmosphere, because you're having a turning motion, is breaking the cap that would normally be in place when you're losing your instability. And the mid-levels of the atmosphere are still unstable. Let's say 925 millibars on up, okay? So your normal stable layer, okay, so here's the surface. Here's your surface, right? And up here is the mid-levels where you have your instability. And so what the jet does is that it acts like a cup and does this and breaks the cap. So as it breaks the cap, the thunderstorms are able to grow. But it has to be timed just right. You see, if you just have a strong jet streak moving through, it may not break the cap. Okay? You could have enhancement of some thunderstorms with some straight line winds, but it doesn't create a new thunderstorm environment. But if you have an 850 millibar jet intensifying at just the right time, like what we have right now, that's when we start to get that mixing, and that's when we start to get our interaction. Now, if all this was occurring at like 2 o'clock in the afternoon, then yeah, these storms would be even more impressive. So definitely. There's a turning of the storms to the north and some more shear that could cause a spin up. In this case, no. I'm not seeing that indication. These thunderstorms are lifting to the northeast mostly because of the mid-level shortwave associated with it that's lifting through. It's not creating any additional vertical wind shear or directional wind shear thus far that we have seen, but it is causing that outflow boundary setup. So that's something that we're definitely going to have to watch. Just saw some garbage cans go down the road. How's tomorrow looking for travel? Tomorrow's looking outstanding. Lower humidity, very comfortable, very pleasant weather conditions overall. Steve, Long Island has been missing the rain and thunderstorms lately, mostly going to the north and a lot going to the south. Why? Part of it has to do with these are all convective systems, and Long Island is basically submerged in a stable environment. The fact that Long Island has been relatively cool compared to the surrounding area due to the southerly winds coming right off the Atlantic Ocean leads to a more stable environment. And so what typically happens is that your thunderstorms tend to lift and move through more favorable environments, which happens to be unstable environments. And so what you start to end up is kind of a convective feedback. So on one hand, it's good because you're staying relatively cool compared to the rest of the region with the onshore flow, but also it's killing your chance for rain. What you want for rainfall is really a sustained extratropical storm or a tropical storm that produces widespread rainfall for everyone. You're going to have a hard time pulling off convective systems. Now, if you have more of a westerly wind than a southerly wind, you'll have a better chance. But with the winds coming in from the south, you're transporting a stable environment right in from the Atlantic Ocean. Lost power due to lightning strike for a bit. Yeah, that's exactly why we have the generator. Missed about 10 minutes of chat. Lost power briefly after very strong winds. Winds staying strong after the initial burst. No hail or heavy rain yet. Still mostly lightning and wind with some rain, but not torrential. So in the premium chat, we see basically the evolution of our storms playing out. Now, holy smokes, I just saw YouTube. Holy Bob
Yeah, I
Dole.
told you.
Wow, I'm going to be busy. Alrighty then, let's see what we got here. Electricity with these storms 3 nights ago. I got about 15 minutes of video down at Jersey Shore. I'm 37, watching the weather since I was young. Whoa, thank you for joining, Morpheus. Peace and love. There you go. Let's see here. Yes, you said it would be at the time to start a live chat, starting for thunderstorms to start. Yep. Some isolated cells popping up south of the initial line on the HRR. Do you know how substantial that is? We're watching that right now. I think these thunderstorms that do pop up are going to be more of the heavy rainfall variety, and God knows we need it down here in Monmouth County. I don't like the idea of any type of tornadoes around central New Jersey, at least not yet. And we actually got some on X. I just saw a impressive video of a tornado moving through. Let's see here. What else we got? Also, is there a possibility for supercell modes later tonight? No. This is all linear. Supercells, that is where you definitely want a unstable environment, instability, and all the rest. It's very hard to pull off supercells in this part of the country at night. Typically, when you're looking for that, it's kind of more driven by what goes on in the plains with a cold front, dying cold front. Even that's difficult to pull off. Typically, your supercells, if you get them around here, they're going to have to be during peak time periods of instability. Let's see here. Traveling to Lancaster, PA tomorrow. Look, everything for tomorrow is going to be fine. These storms, that's the good thing with these storms. By tomorrow morning, you'll have a few lingering showers, and then it's gone. And you're going to notice a big difference in the relative humidity by the time you get to tomorrow afternoon. Let's see. I can see. Is there any way to identify these fronts? Is there a gust front that comes through? Okay, so let's see. That's a great question. How to identify these frontal boundaries? So let me zoom in here and see if I can.
I apologize for my chair.
Okay, so as we zoom in here, how do we know that this is a sea breeze front and this is an outflow boundary? Well, when you're studying where the source regions are coming from, you can see that this is clearly coming off the Atlantic from Ocean County. So this clearly has some sea breeze front properties, or at least some influence from the Atlantic Ocean. This boundary out here is clearly coming out of these thunderstorms and getting ready to clash. So you're having this interaction taking place here. When you are studying boundaries, what you want to look for is what is the source region driving this boundary. So in the case of this boundary here is cooler air, rain-cooled air, coming out of the base of the thunderstorm and pushing to the south. And that is what is causing that outflow boundary. And let's see here. Looks like they're extending the severe thunderstorm warnings into the Hudson River Valley. Let's see how that is going. So basically that just got updated up to here. So what you're seeing here is clearly the shift of the shortwave associated with this is lifting up more towards Connecticut, the Hudson River Valley, and eventually heading towards New England. It's going to clip. Let's see if it's going to clip portions of Queens. This is going to get interesting as we watch the game live here. You can see you got the first rainfall coming through. You got this little cell that is popping in through Staten Island that is going to be heading just to the south of Citi Field. So the bulk of this, I think the strongest part of this is going to collapse here, and this part is going to remain stronger and shift up northward. I would not be surprised if they have to delay the game a little bit based on some of these showers come through. It's going to get interesting, and those winds I was talking about are starting to pick up. Now, not much is going on to the south of here, right? But off to the west, you can see our line coming through. This is going to intensify along with these cells taking shape here as our 850 millibar jet intensifies. So that's what we're going to be watching out for over the next 2 hours. I won't be live for 2 hours, but over the next 2 hours, you're going to start to see that evolution really start to take place with this 850 millibar jet. In fact, let's see if we refresh this to see if we get any new data here on this. Hence some of the lifting here. We'll zoom in.
You also have some stuff on Twitter and Facebook.
Oh, okay, what do we got on X? Alrighty then.
I mean, some of the down at the bottom of the
It was wicked here. Look at my feed if you can. Yep, I'm looking at it. Passed through Somerset County, had rotation. There wasn't anything on the radar, but I wouldn't be surprised if you experienced a mesoscale low that caused some of that rotation.
And there's Facebook.
Hi, Facebook. Hi, everyone. Will the severe thunderstorms do damage in southeastern Pennsylvania, southern New Jersey, Delaware later tonight? Okay, so those locations, I'm more concerned about straight line winds and downburst wind gusts. So there's definitely that potential for wind gusts over 50 miles per hour, very heavy rainfall, frequent vivid lightning in those areas. I would definitely say that would be the highest potential.
And you have more on YouTube as well.
Oh boy, look at this. We are having a busy night tonight. What's the likelihood the heaviest rain wind will pass through Newark, basically northeastern New Jersey? Well, it's basically doing so right now, so I would say it's a pretty good shot. Let's see what we got back in. Let's see here. A lot of lightning right now. Would not be surprised to lose power again. Oof, wow, we got very busy in live chat too, so let me catch up on that. Very strong winds. Wind staying strong at the initial burst. Okay, all right, so here we are. Lots of lightning. With the heavy rain, watch for downburst winds. Yes, absolutely. That is a major concern in this setup. Let me pull up the radar while we're talking. That way you guys can watch the evolution of these storms taking place. And we just got a new tornado warning out here towards south central Pennsylvania. So these storms are packing a bit of a turn. You know what? Let me go pull this in, and then I'll get back to answering some of these questions. you can see the circulation here. So what's happening is that you're getting, let me wait for this to load before I explain this. It's getting there. Okay, so you have this solid line marching through. Now you see these little kinks in here? See how it's kind of like a little S here, a little S here? What you're having here are these little mesoscale lows developing at the tail end of some of these thunderstorms. And it's creating enough of rotation that it's leading to the signal of some potential tornadoes indicated on radar. We haven't had any indication of observations on the ground based on what I'm seeing with social media feed. But you're seeing enough rotation that, hey, we should warn this just in case. So that is essentially what you're seeing here is these mesoscale lows within this line marching their way through. Now the question is, and this is why I kept the threat for isolated tornadoes alive, is that this line is going to be marching through around midnight or so through central and southern New Jersey and southeastern Pennsylvania, and you're going to get some of that mesoscale mixing and mesoscale turning in the atmosphere. Is this line going to hit New York City or just north of the city? Looks like it's going to be clipping New York City, and the brunt of it's going to pass to the north of New York City, but you're still going to get some rain out of this and maybe a little bit of thunder. But the worst of it, I think, is going to stay to the north of New York City. The rain was needed given the last round of storms pretty much completely missed my area. Yeah, we need rain here in central New Jersey. In Freehold, I'm running around trying to save our shrubs, like dropping buckets of water because we have water restrictions, and it's just crazy. Mid-level lapse rate seems to be pretty decent per the SPC. Yes, it is. This is what we were talking about. Let me pull it up here. When we were talking about breaking that cap, okay, the lower levels are feeling some of that cap because it is getting cooler, right? Because it's nighttime. But if you could break that cap with your jet streak, you can see the instability here is pretty good. That's along the coast. So in this environment, that is essentially what we have to work with. I gotta drink some water. I'll lose my voice. So it's certainly a very active evening. Look like the two fronts are about to collide. Let's see.
Some people seem to be excited.
Flight is landing at 11:30 p.m. Woo! Yeah, I'd plan for it. See, it's always difficult to decide to try to figure out what's going to happen with airlines landing and whatnot. I would prepare for the worst and hope for the best when it comes to the airlines and thunderstorms, because sometimes it's not just how it impacts your area, but the whole flight path. If it alters the flight path, it could alter your flight in taking off or landing and leading to all sorts of havoc. So it's not always just what the conditions are at Newark, but what are the conditions within the flight path of wherever you're going and where other planes are going that can impact your trip. But yeah, not the best conditions tonight, that is for sure. Look, New York City. Okay, this is a great question about tornadoes in New York City. It is very, very difficult to pull one off, especially in Manhattan. And the reason why, actually, you have a better shot in getting a tornado in the Bronx, in parts of the Hudson River Valley, northeastern New Jersey, than in the heart of Manhattan. And part of that is because the heart of Manhattan is in the heart of the urban heat island effect. So when we talk about the urban heat island effect, it's not the island itself, it's the gradient. So if you are to the east or to the northeast or northwest, I say, of that gradient, that's where you have your chance of seeing some enhancement. It's very difficult to pull that off in Manhattan itself. Actually, you probably have a better chance of having, I would say the bigger thing would be the flash flooding. I just got a report. Newark, New Jersey airport radar detecting 80-mile-per-hour winds around Bayonne, New Jersey. So there you go. Doppler radar indicated. So you can see the strong winds associated with these storms. You get enough mixing, you could definitely create some havoc in that respect. Yeah, we're not going to do every borough. Sorry, guys. Let's see what's going on with our interaction here. And let's see, we haven't seen anything fire off just yet, but we got time. If the HRR is accurate, we will see any thunderstorm that starts to fire off right towards the end of this live chat, around 8:50 or so. We'll see if that actually works out. But you can see the boundaries are now interacting. So we'll see if we actually get something to fire up or not.
You're picking up traction on Facebook.
Really? Okay. Well, do we have any more questions?
Just trying to keep up. No, really, because I'm hopping around, so.
All right. Let's see here. Okay, New Jersey, will these storms fizzle into heavy rain? Most of these thunderstorms are just going to feature very heavy rain, vivid lightning, though, and definitely strong wind gusts. So, yeah, not every thunderstorm is going to be severe, but they'll certainly pack a punch. Finally catching on one of your lives, also always great info. Thank you, Northeast Nick. Yep, I don't want to say your live name. I don't know if you want to do your stage name. I know people are very particular about that, but thank you. So the evolution that we're seeing here, this is a great time to talk about convective weather, okay? To talk about the forecasting of convective weather. Because a lot of people say, well, you know, we had severe thunderstorm warnings, but I didn't get my thunderstorm. This evening, we're seeing right now just how complicated and tricky this environment can be. Because as you can see here, we're not just dealing with synoptic scale events where we're talking about the jet streak and whatnot, but we have already talked about the interaction of the urban heat island effect, which is a microscale effect, the evolution of our sea breeze front and outflow boundaries, and how they all work together to interact. You okay?
Yeah. Sorry, I'm fighting my hair.
Interact together to set up these storms. So we're watching live the interaction of all these features. And so with that, there's going to be a lot of error. So when we're trying to forecast, when you start to get like a severe thunderstorm watch, right? I've seen way too many times on social media, oh, well, I had a severe thunderstorm watch. It busted because I didn't get a severe thunderstorm. That's the most egotistical, irresponsible, childish point of view that you could possibly have. Just because a severe thunderstorm watch doesn't happen in your backyard, or a severe thunderstorm doesn't happen in your backyard, doesn't mean the watch busted. It just means you got lucky enough that your property didn't get destroyed by straight line winds, hail, heavy rainfall, flooding, tornadoes ripping apart your house. Oh yeah, how horrible. So, you know, when discussing severe weather and severe thunderstorms, it's not like forecasting for snowstorms, where it's more of a synoptic scale event. Even that has mesoscale properties, as you know. But forecasting for synoptic storms like snowstorms, like widespread rainstorms, is a lot easier to do than forecasting for severe thunderstorms, because you're dealing with a lot of small factors that create a lot of chaos. And we're seeing that live tonight with this band moving through. And, you know, it lost a little bit of its punch, but it still has some very impressive winds, and it's driving right through Newark and heading right into Long Island. Now, what's going to be interesting, let me pull this up because this is really cool. Okay, so let's pull up the surface-based lifted index. Okay. Now you see Long Island here. We were talking about this beforehand. Why? How come in Long Island I'm not seeing my heavy rainfall? This is why. Right here. Stable air trying to push in while you're getting all this instability. So this thunderstorm line is marching right in to this far more stable environment that's in place. So what we're going to be watching as it does so, and you can already see it somewhat in the radar here, some of these cells starting to lose their punch as they're moving into Long Island because they're moving into a more stable environment. So as this is all taking place, it is setting up a weakening event for these thunderstorms. So while Newark is going to get hit with a pretty good punch, as it already has, I think the rest of Manhattan and the rest of Long Island will see rainfall, but nowhere near as the intensity of what we're seeing in northern New Jersey because of that stable environment. Meanwhile, we still have our lines marching from west central Pennsylvania towards the region. This line looks very, very active, very vivid. I am very concerned about the way that we're seeing this signature here. Let me zoom in and turn. Okay, you see these little kinks here? This has me concerned for more mesoscale lows. Let me see if I can pull up more data on this. Let's see here. Do I have storm tracks? Yeah, here we go. Let's see if we have any mesoscale lows out of this here. We might have something here. Okay. So 54 max height, echo height, 10,300 feet, no TVS being reported. Here we are. Here's one cell with a mesoscale low. Hail size about 1/2 inch in diameter. It's featuring 2 mesoscale lows within it. This one right here. So you're seeing some 4 meso. So these thunderstorms. Oh, we got storm cell pit LO. No mesoscale. Max height 7,100 feet. Echo height 14,100 feet. Moving at 38 miles per hour. So these storms are really booking. They're moving pretty fast too. Let's see. Let's use the same data and take a look and see what we have towards the New York City Metro. And again, you can see this line as it's starting to interact with this more stable environment. It's starting to lose some of its punch. But take a look at the storm tracks here. Okay, this is something, I don't know if you guys ever noticed this or if you have the capability to look at this. Notice the individual cells within the line are all moving in all sorts of different directions. And when this happens, it leads to sometimes enhancement and weakening of these cells as they interact. So you're seeing this. So you got one cell here. Let's see, probability of hail 50%. You got a nice hail shaft here. You got another one that's moving away from there with a mesoscale low, enhancing heavy rainfall. We just got a new update, and now we're seeing this one that's moving towards Manhattan. It has a 90% chance of producing hail. That's pretty impressive. And that is getting very closing in on Manhattan. And it is directed to pass just to, heck, that might just move right over City. That just might move right over City Field. That would be something. So yeah, this line is definitely very impressive. Let me get back to see if there's any other questions here. And we certainly have quite a few, so let me get back to that. Let's see. Mid-level. All right. So Queens has gotten them. I recall a couple of storms and circulations popped up just west of northern New Jersey. I-95, Middlesex and Union crossed over and made it to Queens. had tornadoes reach the ground. I remember one tornado a couple years ago that got into Queens and like completely messed up a street, ripped apart a bodega. So definitely you can get them. It's very hard to pull them off in Manhattan. Oh shoot, Mets are really whacking the ball. Look at that. And I think we got 4-0 Mets. Sorry, I'm living in. This is like great. I'm just having a very, very nice night in that respect. Looks like a pretty heavy cell moving into Linden. That one in PA looks like it's turning into a large frontal mesoscale low with smaller mesoscale lows embedded. Yeah, it might be. It's getting pretty damn close to pulling that off. It's not there yet, but it's getting pretty damn close. Let's see what we got on YouTube. Holy smokes, we got a lot of things on YouTube still. You can see the CBs. Let's see here. I'm going to try and pick the best one here. One question I've always had is how do these storms keep or build intensity when the sun starts going down? We talked about that. That's the 850 millibar jet. And there's the rain that just hit Citi Field. Boom. Well, there you go. Called it. Let's see here. Wind pretty fast. Let's see. First flight in Newark. New York City has seen hail, but they haven't seen tornadoes. Let's see. Any questions on Facebook?
Nothing
Nothing new on X.
Check again. Same as it was. X is the same.
So, as expected, hey, it looks like the baseball forecast worked out with the idea that, hey, look, you're going to have delays. The one thing, if you're at Citi Field or you have friends at Citi Field right now, once this line goes through, you got about a 2-hour break, and so they'll most likely delay it and then come back to it probably around 9:30 or so. So they'll probably start the game back again around 9:30. But this line, the good news, like I said, is weakening. It's starting to lose some of its punch. Let's see what we got in new HRR data. Let's see if we got anything that stands out. And the latest HRR data, which again, we'll see. See, the problem with this HRR data to begin with is that, and this is actually a great experience. This is great because now you're going to see why you shouldn't use HRR all the time. Look at what it's doing at 9. Let's pull this back to 8:45 p.m., which is right now. And according to the HRR, there should be no rainfall in Queens. Obviously, that's not the case. And according to HRR, the core of the cell should be up here towards northern New Jersey and the Hudson River Valley, and maybe an isolated cell just over southwestern Connecticut. So what does this mean when we see this? It means you could throw it out. Okay? Because the reason why it's important not to use this model at this time is because if it's not picking up the thunderstorms here, then it's not creating the proper outflow boundaries, and it's not creating the proper intensification out here of these storms. Also, with it not handling the proper boundary layers and the frontal boundaries down here, you're not going to have the proper enhancement for when this comes in. So what it does, it doesn't produce much of a convective setup around central New Jersey. Still some very heavy rainfall moving through overnight tonight, but possibly this may be underdoing the intensity of those cells with those different boundaries heading out. And we have to remain skeptical of this guidance because of this factor right here. 9 p.m., no rainfall over Long Island. Well, let's take a look and see what we have right now. And clearly, we have rainfall over Long Island, over western Long Island, with heavy rainfall and severe thunderstorm warnings being issued. So, as you can see, this is when you take that HRR guidance and throw it out, and you just use the radar data. And that, ladies and gentlemen, is meteorology, not modelology. Let's see here. We got more questions in the premium chat because, as always, we answer all the questions there, unless I lose my voice or pass out. They are rolling up the chart. Yep. Non-stop lightning here in Manhattan. Quite a show. The storm has been such a focus. Hasn't even talked about the PDO or La Nina. Sahara dust. Yeah, that's going to be tough to talk about tonight. So, you know what, let me touch on it. I don't have any data to pull up, but let me touch on some of my thoughts here. Okay, so PDO still rocking along. This La Nina is going to be a lot weaker than what a lot of people thought, even myself. I thought it might be weak to moderate. This La Nina might be neutral cold to very weak, which has a lot bearing on the forecast for the hurricane season, the fall, and even, in City Field, they just put up on SNY the rainfall. It's like a freaking hurricane out there right now. Very impressive. And it also impacts the winter pattern. Okay? Anyone who canceled winter already, you might want to backtrack. Because that La Nina is not very impressive. So we're going to be dealing with a different pattern. In terms of the hurricane season, with the very weak signal of La Nina, the potential for more vertical wind shear and more dust coming off the Sahara Desert is enhanced. And it's why I'm not so gung-ho with some of the disturbances out there. I know the NHC is very active because of the warm waters, but right now, I barely have a circulation. I have a ton of dry air that's stabilizing the thunderstorms. I'm not saying it won't develop. I'm just not as enthusiastic or as confident.
Hi.
Yep.
So somebody in the Facebook
Yep.
messages said that their friend texted them and said that it's hailing at the Mets game.
Wow. That must be... Okay, hold it. Let's see here. Let's pull up. Let me go back to here. And we'll get back to your questions in just a moment. Let's take out some of this. Take out the lightning. We'll take out the storm tracks. Let's see if we can zoom in a little bit more. Okay. So, see, it feels right about here. What you're seeing here... Oh, wow. Okay. Take a look at this. You had these two cells merge, take shape, and then you had the enhancement of the hail shaft right here. That's what you're seeing in City Field right now. These thunderstorms came together and started to interact and merge together, and that enhanced the lifting. Yep. I see. Yeah. This is... Here, let me just see if there's any other... It's just impressive. And the thing that's mind blowing is the beautiful chaos in all of it. Why are we seeing a delay at City Field? Because these two thunderstorms, rather than separate, merged right over Long Island, and it merged due to the lifting. It's tried to move over the stable layer, and so while doing so, it was able to merge and interact with each other to enhance the vertical lifting to produce a hail shaft strong enough to impact parts of Queens.
Clouds are moving fast out here.
See, that's a great observation as well by my wife. Now, the reason why that's important is that that's telling us...
I don't think they heard me.
Oh, well, Susan just said the clouds are moving really fast around here. That's because of the enhancement of the 850 millibar jet. That enhancement is happening right now as we speak. And that is what is enhancing some of these storms. And, oh, hold it. Let me zoom out. There it is. There's the first spark of convection. We just heard thunder. And here's some other cells starting to pop up. Let's see. We might have just seen our first cells starting to pop up with that interaction. A cell just to the north of where we're located. A couple more starting to pop up. It's starting to get itself going now. So the theory involved with the thunderstorms, with these outflow boundaries interacting, is actually unfolding as we speak. That's awesome. That is cool. Let's see here. Let's see here. Let's see. The straight line winds in New Jersey were intense. 3 reports of trees down around me, and the lightning was very vivid. It sounds like a freight train moving through. How does a weak east-based La Nina do for us in the winter? I don't want to go into too much details right now because I'm kind of going off the top of my head. But in my experience, what you have is you still have a stronger polar jet stream. And you still have some representation of a southeast ridge, but more displaced towards the Bahamas. Less potential for nor'easters, more potential for a lot of isotropic lifting storms. Like let's say where a warm front is approaching and cold air is stuck. So a lot of ice and snow to ice events. But that's very generic. There's a lot of work I need to do to really break down exactly what to expect for this upcoming winter. Well, the one thing about Citi Field, I know about this personally, is that the drainage system in the stadium is very impressive. They should be able to play once it gets done, but we'll find out. We shall find out. The line is moving very quickly, so that is somewhat good news. The back end of it's already starting to move through Manhattan, and you can see the collapse of it. But again, we're starting to also start to see the convection start to fire up here over central New Jersey. You can see that starting to take shape here, and you can see the more vivid line taking shape, the more solid line taking shape off to the west. Zoom out a little bit. I would not be surprised if we start to lose some of our tornadic ability with this line, but it just concerns me when I see this type of S. That's a lot of mesoscale lows creating a lot, and you're having a lot of downburst wind gusts, a lot of straight line winds in this event, all marching towards us. So, and I haven't even gotten into a lot of the other stuff that we normally talk about, the seasonal stuff. I'm not all that impressed with what's going on out there in the tropics right now, but I do expect us to increase in activity going forward. Looks like pop-up storms in Warren, Sussex, Morris County area. Yep, they're all starting to fire. Thunder and lightning started here at 8:50 in Stamford, Connecticut. So we're getting some of that development out there. So a very busy evening. So with it being 8:58 and my throat's starting to give me signs I'm going to lose my voice. And we even have text coming. Oh, okay. So let me wrap up what we can expect for the rest of tonight. And I won't even use model guidance. I'm just going to use the radar here. So for the rest of the night, this feature right here is going to continue to lift to the northeast. This should probably clear eastern Long Island in about another 20-25 minutes. And as it's moving through northern western Long Island, it's going to steadily weaken because it's moving into a more stable environment. Still very heavy rainfall marching through. So there's your rainfall in Long Island. So there you go. Connecticut, you're going to get that wave of thunderstorms moving through. I expect that line to continue to be severe. There are several outflow boundaries out here with this line interacting with this line that's going to create a lot of havoc overnight. Down towards central and southern New Jersey and southeastern Pennsylvania, we're already starting to see convective thunderstorms starting to pop up here with our old outflow boundaries interacting. That's going to continue to grow as we go on through the overnight hours. This feature is going to be reaching us by 11 o'clock midnight, And while the severe threat will slightly diminish, I am still very concerned about very heavy rainfall and downburst straight line winds over 60 miles per hour. I wouldn't be surprised if there's some hail in this as well. Very stormy night overnight. It's going to sound like a freight train in some of these thunderstorms. Tornadic ability, if there is going to be anything left over, it's going to be in this area right here where we're seeing those low level winds interact. So that's going to be the primary theme there, is going to be the very heavy rainfall. And overnight tonight, especially towards midnight, it's going to be a bit dangerous. So just stay indoors if you can. You should be. It's midnight. Go to bed. Just be prepared. Don't be surprised with some power outages, some minor wind damage and whatnot. With that, I think I'm going to call it a night. I think I did. I think I got pretty much all the questions answered, other than the in my backyard. What's going to happen? Some signs of rotation on the northernmost storms warned tornado possible. I don't think I'm not seeing any sign of tornado up here. Oh, I see up towards. Yeah, there's definitely a mesoscale low up towards the Hudson River Valley, but no tornadic circulations being reported yet. But hopefully that remains the case. That's it for tonight. Thank you, as always, for joining live chat. I hope I answered all the questions that you have. And I really appreciate you guys joining. And as always, please, especially tonight, stay safe out there.